For today's notes, you will need IC64. This is part 1 of Standard 15, where we are going to learn about surface area of 3D solids. There is some introductory material for our notes today because we're starting a new standard, so we need to kind of set the stage about, as well as specifically look at the idea of how it works in right prisms. So let's go ahead and get started with some important vocabulary and abbreviations. Surface area is abbreviated as capital S, capital A. And so what we find when we're talking about surface area is the total area of all surfaces of a geometric solid. And so specifically, we will talk about lots of different kinds of solids as part of Standard 15, but our solid for today is a prism. And in order to find the surface area for a prism, we're going to end up taking P times capital H and then adding in 2 capital B's. Well, that's an awful lot of letters, and some of them are familiar, but they're capitalized instead of being lowercase. So we're going to take some time to make sure we understand what each of those abbreviations stand for. P should be familiar to us from our AP over 2 formula that we use during Standard 14 for regular polygons. It is going to stand for perimeter again. But because we're dealing with a solid that's 3-dimensional, you can see some of them at the bottom of the screen right now, we need to be specific about what we're finding the perimeter of. So the perimeter needs to be of whatever is considered the base of the geometric solid. Capital H is going to be a height, like lowercase h was in Standard 14, but the height has to be of the entire geometric solid, which means it's really describing the distance between the bases of the solid. And then capital B represents the area of the base of the geometric solid. And because we're dealing with right prisms today, the bases are always going to be parallel to one another, and they're going to be congruent, and they're going to be connected to one another by rectangular faces, so by rectangles. Okay, so because there's a lot of vocabulary and because identifying the vocabulary is so important, we're going to spend the first part of our notes today really focusing on identifying these key features in the prisms. So for each prism below, we're going to shade a face that could be used as the base. That's our first thing. I'm going to do that in yellow. Then we're going to highlight and label a distance that represents the height. I'm going to do that in green, and this is going to be the capital H height that we were talking about. And we're going to talk about giving the prism a name based on its features. So let's go ahead and start. If we're looking at this first prism, we need the base, remember, to be the sides or the faces of the prism that are parallel and also congruent and connected to one another by rectangles. So a lot of times we look at the bottom or the top of the shape to see if it could be a base. Does the bottom seem parallel and congruent to the top, and is it connected, or are they connected to one another by rectangles? And the answer is yes. So we could shade the top of this and call it a base, and we could shade the bottom of this and call it a base. If we do that, if we make that choice, then that capital H height is going to be what connects those bases together. So we could label it right there, connecting those back corners together. We could label it right here, or we could label it over there, or in the back we could label it. Lots of different options, but all of those distances would be the same because we've got this parallel congruent base situation happening. Now, when we look at this base, it definitely looks slanted like a parallelogram, but the reason that that happens is because these are drawn with perspective so that your brain gets tricked into seeing them as 3-dimensional, even though they're all on a flat piece of paper. And so what happens when we have something that looks like this is that it's actually representing something rectangular, It might be representing something square, but we don't know that because we don't have measurements showing us that these match. But what we do know is that it's going to be rectangular. So we could imagine right angles in the corners of the base. And then it's going to be a prism because it fits the characteristics of a prism. Two congruent parallel bases connected by rectangles all the way around. This looks a little bit messy, but that's just a right angle box. Okay, so when we move to the next one, we're looking for the same thing. We're looking for a face that could be used as the base. So when we're looking at the bottom and the top this time, they look different than before, but are they parallel and congruent, and are they connected to one another by rectangular surfaces? And the answer is yes. So we're going to be consistent, and we're going to use the bottom of this prism. That will be shaded as a base. And the top could be considered the base, which means, again, our height, our capital H height, the distance between the bases, could be any of these segments that connects corner to corner from the top face that's the base and the bottom face that's the base. Now this time, those bases have a triangular shape, so when we're naming our prism, we're going to call it a triangular prism. All right, moving on to question number 3 and 4. We're going to work on the same thing. Looks like that got a little bit blurry, so let me make sure you can see here. Okay, if I'm investigating number 3 and I'm looking at the bottom to try to identify the base, I'm not seeing a surface there. And in fact, I just see a segment at the very bottom of that. This looks kind of close to the bottom, but that seems rectangular to me, and so does this front face right here. What seems different than the rectangles would be over here on the left, which matches, is congruent to, and parallel to what's over here on the right. So this time, our prism is kind of tipped up on its edge, and those bases are on the left and right-hand side instead of on the top and the bottom like they were in the previous 2 examples. That also means that our height, instead of traveling vertically, is going to travel horizontally. So our height's going to be back and forth in between those 2 left and right bases. Now, if I look at what's happening here, this base has 1, 2, 3, 4, 5, 6 sides. So from my standard 14 work, I know that's a hexagon. So this is going to be a hexagonal or a hexagonal prism. So we name our prisms based on thinking about the shape of the base and then saying that it's a prism. All right, last but not least, we have our 5-sided shapes here, it looks like, that are connected by rectangles. So we've got that one, which could count as a base, and then also this one here, which would be the second base that's parallel and congruent, which means our height is going to be one of these connecting distances vertically again in the picture. It looks like we've got 5 sides this time around that base shape, so that would be a pentagonal or pentagonal prism. Okay. So a couple more things for us to think back to the past on, and then we'll see how we can put this all together to find surface area. Capital B is going to be related to the base that we shaded in. And so in this first problem, we saw that the base could have a rectangular shape. So if we're going to find the base area, the capital B part of the formula for surface area, we're going to have to go back in our memory banks to standard 14, where we had these formulas right here, and remember which one of these was for rectangles. That should be lowercase bh. So there is a definite difference between a lowercase b and a capital B. Remember, lowercase b would have been any side of the rectangle, and then lowercase h would have been the side of the rectangle that forms a right angle with the one that you chose for the base. So if we come back up here to our first rectangular prism, capital H is in between the bases, but lowercase b and lowercase h would be flat on that bottom or up here on the top part, connected to the base of the shape only, not describing the distance between the bases. Thinking about triangles, back when we were finding area of triangles, we use lowercase b, lowercase h divided by 2, which if there was a right angle in a triangle meant that we could use 2 of the sides. So it might look like that with the base and the height. Or if there was not a right angle visible, then we often drew our height in through the middle. And so if we pop back up here to number 2, it's not super clear whether we have a right angle or not. But if we knew that this was a right angle, so I'm going to add that onto the diagram, then we could use this edge right here as our lowercase b and this edge right here as our lowercase h. Otherwise, we would have to do more work to figure out where that height is at if that right angle was not given to us. All right, and one more. If our base is a regular polygon, which is what we have going on in these two situations, then that capital B formula is going to be AP over 2. Remember that A was the apothem value that was perpendicular and intersected that side at the midpoint. And then the P, grab a different color, was the perimeter all the way around that shape. Okay? So if we're looking at these prisms that have regular polygons as faces, we would have an apothem that's laying flat on the bottom or flat on the top of that shape, and then we would have this distance all the way around the shape that would be the perimeter. So we would just be focusing on features for the bottom to find that capital B or features from the top to find that capital B. Over in number 3, that's going to look a little bit weird because the bases are on the left and the right. But again, the apothem would start in the middle and travel out to the middle of the side. And then that perimeter would be the distance around that base. So not necessarily at the bottom of the shape this time since it's tipped up on its edge, but around whatever that face is that's acting as the base. All right, go ahead and flip to the next page and meet me over there for some examples. All right, first things first, by the time we get to the end of this standard, you're going to have multiple formulas for surface area. So I'm just going to give you a sneak peek ahead. This is what we're working on today with prisms, P times capital H plus 2 capital B. But then we have 4 other formulas that are also going to give us surface area for other geometric solids. So even though today every single problem is going to use PH plus 2B, I'm going to write that down every single time I start as soon as I see that I'm dealing with a prism. So my game plan for surface area is P times capital H plus 2 times capital B. That means that I need to pick a base before I move on. So because all of the faces here are rectangular, I could choose the front to be the base if I wanted, or the side. But for most people, they prefer for it to be the bottom of the shape when they can. So we're going to use the bottom, or we could use the top as the base. So when it comes to finding P, we're going to be focusing on the perimeter of that base shape. If that base shape is a rectangle, there are going to be 2 sides that are 4, the front edge and the back edge, and then 2 additional sides that are 5. So I can find the perimeter by doing 2 sides that are 4 and 2 sides that are 5, which gives me a total of 18. So that's going to fill in the perimeter part of the formula. For capital H, remember that's the distance between the bases, capital H. There's nothing here, but if I keep investigating other places that show me the distance between the bases, I find a number over here on the left side, 6 inches, that I can use as the height of that prism. Next up, I need 2 times capital B. Well, capital B is going to be something that I need to solve for based on the shape of the base. If it's a rectangle, that means I'm doing lowercase bh. I have a side of the shape available for lowercase b and a corresponding side that makes a right angle available for lowercase h. So my base area, capital B, can be found by doing 4 times 5, which gives me 20. You can multiply it in parts, or you can take care of all of the multiplication at once. So we need to do 18 times 6, and then we need to add on 2 times 20. And when we get to the end of all of that, we're going to end up with a surface area equal to 148 square inches. We're still in area mode, so we're still dealing with square units. All right. Onward we go to the next problem, which I can tell is already a prism. That means surface area can be found using the same formula as before, P times capital H plus 2 capital B. I'm noticing that I have a shape in this prism that is not a rectangle down here at the bottom, which corresponds and is parallel and congruent to one up here at the top. So this is actually a triangular prism, which makes sense. That's what they told me. For the P, I need to focus on finding the perimeter of the base. So if I investigate the bottom, I'm noticing I have a 9 available, but I'm missing these 2 sides. If I investigate the top base, I have a 15 available, but I'm missing these 2 sides. So what we need to do is realize that we can take our measurements from one base and move them to the other. I'm going to take this 9 and move it up. But that still means that I'm missing this value right here. So we need to find what that's equal to using one of our old standards. You can call it an X, or if you're good enough to think ahead at what this area formula would be, you might call that the lowercase h. That's going to be the height of this base. This is, it looks like a good opportunity for me to use Pythagorean theorem. Across from the 90 gives me my C value, and then I have 9 and that lowercase h left. Go ahead and square everything and then work on subtracting. Finalize it by square rooting both sides, and we end up with an h, lowercase h, equal to 12. So sometimes there'll be part of your values, part of your picture that's missing, and you'll need to find it. Once we have that tracked down, our perimeter is going to combine the 9 and the 12 and the 15, all 3 together. 9 and 12 gives us 21, plus 15 more gives us a perimeter of 36. Capital H, distance between those bases is right here on that left-hand side. So we're going to multiply by 10. That's our capital H height. And then we're going to need 2 base areas. Since our base is a triangle, come over here to the side and remember our triangle formula for area. If I'm using this as lowercase h, I want to use that side then as lowercase b, since they make the right angle. So we'll do 9 times 12 divided by 2 to find the area of each of those triangular bases. 9 times 12 divided by 2 gives me a base area equal to 54. So when I go ahead and plug that in up top, I'm ready to do my calculations. 36 times 10, so that'll be 360, plus 2 times 54, or 108, leads me to a complete surface area of 468 square inches. All right, 2 down, a few more to go. So on to the next one. We've got a regular hexagonal prism with an apothem of 5 root 3. They want us to give an exact answer and round it to 2 decimal places. So we're going to try to show both. All right, prism surface area is going to be P capital H plus 2 capital B. Since they're calling this a hexagonal prism, that means that the hexagon is going to be the base shape. So we could shade that in if it helps us to visualize what's going on. That means that when I'm thinking perimeter, I need to be able to find the distance all the way around one of these bases. And as I'm thinking about that, I'm noticing there's nothing labeled there at all. So it's going to take me some work to track down the perimeter this time. I do see an 8 available in between those bases to use as the capital H, so I have that available. And then for capital B, since we're dealing with a regular hexagon, we're going to be in AP over 2 mode. So I think what makes the most sense, instead of trying to draw in these kind of squashed looking hexagons, is to pop out to the side and draw my normal picture for hexagons. So remember, we have an apothem actually given to us. So I'm going to put 5 root 3 here equal to the apothem. That makes a right angle with a side that gets divided in half. And then this is a radius. We are missing information about the side. So I'm going to find this angle at the top. For a hexagon, that's 360 divided by 12, which gives me 30 degrees. So we are in a situation where this is the L root 3 side. So if L root 3 is equal to 5 root 3, then that means the shortest side, the L, is equal to 5. So I can fill that in and figure out my side length is going to be 10. If I needed the radius, I could find it, but I don't. Perimeter then is going to be 6 sides that are all equal to 10. And we're going to use that actually in 2 parts of this calculation. Perimeter shows up in the surface area formula, but perimeter also shows up in this AP over 2 formula. So that 60 is going to get used twice. The apothem was given to me as 5 root 3. So I'm going to keep this base area exact for right now and do 5 times 60 and divide by 2. That's going to round out to be 150 root 3 for base area. If I plug everything into my formula, perimeter is already taken care of. Capital H height between the bases is 8. And then we're going to add in 2 of our bases that are 150 root 3. To keep this answer exact, I'm going to have to multiply what I can, which means 60 times 8. And 2 times 150, but then because these don't both include root 3, that would be it for an exact answer. So our exact answer would look like this, 480 plus 300 root 3. Now because they also asked me to round that answer to 2 decimal places, I'm going to go ahead and type that whole thing into my calculator. So we'll have 480 plus, not 600, 300 square root 3. And then that's where I'll take a look at that second decimal place to see whether or not it should stay or round up based on the third. So since that's a 5, we're going to round that up to a 2, 999.61. So surface area is approximately 999.61 square inches. So we do want to pay attention to whether we want exact answers, which means sometimes they'll stay as addition problems, or rounded answers, which means we can go ahead and calculate everything. All right. Regular pentagonal or pentagonal prism. So again, we know we're in prism mode, which means surface area equals P capital H plus 2 capital B. Since they're saying that we use a pentagon as our base, we're going to focus in on either this top shape as the base or the bottom, or if it helps you to see both, go ahead and shade both of those in. Okay. That means when we're looking for this perimeter, we need to know the distance all the way around this 5-sided pentagon shape, which I think we can find because I ran into a 6 as I went. So there are going to be 5 sides that are all equal to 6, which means our perimeter is given as 30. Next up, I'm looking for the distance between those pentagons, so I also have a capital H available to use. So all that's left to do is to figure out this capital B by finding the area of that pentagon using AP over 2. It doesn't look like I have the apothem given to me this time. I don't see it in the diagram and I don't see it in the instructions. So if we set up our diagram and we put that A value on there to remind ourselves we're looking for the apothem, we do know that an entire side is equal to 6, which means it gets split in half, 3 and 3. We can find the angle at the top by doing 360 divided by 10 this time, twice the number of sides, which will give us 36 degrees. So instead of being in L root 3, and 2L mode, we're going to be in SOHCAHTOA mode here, where we have an opposite and an adjacent available based on that 36 degree reference angle. So a quick tangent equation, tangent of 36 equals 3 over A. That's going to get solved by multiplying both sides by A, and then dividing both sides by the tangent of 36. So that apothem value is going to be given by doing 3 divided by tangent of 36. 3 divided by tangent of 36. So although we're going to write that down, the apothem is close to 4.129. I'm not actually going to round it because this is nowhere near the end of my calculations. So I'm going to keep that apothem value in my calculator, 4.129 with a bunch of decimal places. I'm going to multiply that by the perimeter of 30 and divide it by 2 without multiply by 30, divide by 2, which means my base area, if I were to round it, would look like 61.937, but I'm not rounding because I'm going to take that now and finish out my calculation. So there are 2 of these necessary. I'm going to go ahead and multiply that by 2, and then I'm going to add on to that the 9 times the 30. Since addition is commutative, we can work backwards and everything will still give us the same answer. Now is the time when I officially round at the very, very end of the problem. So 393.87 square inches. We work to keep those answers as exact as we can until the very end of the problem. Okay, one more problem here for us to finish this out. We have a triangular prism again, so that means that this front triangle or this one on the back would be considered our base. We're still in prism mode, so we're still doing PH plus 2B. When I'm looking to find the perimeter, it needs to be of the front triangle or the back triangle. 2 of the 3 sides are available on the front, so I'm going to pull that 10 up there as well, which means perimeter will be 10 plus 10 plus 12, or 32. Next up, I need the height. The distance between those bases right there is 20. And then all that's left is to figure out that capital B, which is the area of those triangular bases. Now, when we look at the triangle, there is no right angle in sight, but we do have 2 sides that match. So thinking back to standard 14, we're going to drop our height down through the middle, which is going to split that 12, 6 and 6, and give us a little Pythagorean theorem opportunity here, where 10 is C, and then 6 and H are the A and the B. 100 will be equal to 36 plus h squared, which means 64 is h squared. And when we square root, we're going to end up with 8 being equal to lowercase h. The whole base is 12. The height turned out to be 8. So we'll multiply those together and divide by 2 to get our capital B base area of 48. And then all that's left is to calculate it out. So 32 times 20 plus 2 times 48. And our final triangular prism has a surface area of 736. No units, so we'll just call them square units in general. All right, that's it for the surface area of prisms. We will see you back in class. Thanks for watching.